Hello students, today we are going to see the lesson chemical changes and reactions. In today's class, we are going to see what are the types of chemical changes we have. So this chemical changes we can also say as chemical reactions. So in today's class, we are going to see the direct combination, decomposition, displacement and double decomposition. So these are the main four types of chemical changes that we have. In decomposition, we have a further divisions like a thermal decomposition of metal compounds. So how it reacts with metal hydroxides, metal carbonates, bicarbonates and nitrates, that all we are going to see. And also in double decomposition, the further classifications like a precipitation reaction and neutralization reaction. And this is the part 2 video of this lesson. Okay, shall we go to the class? Right. Now, what is direct combination or combination reaction? This combination reaction is also known to be as synthesis reaction. That is a simplified form or very simple reactions. The reactions which occurs with simple compounds by means of this combination type is known to be as a synthesis reaction. So, a reaction in which two or more substances combine together to form a single substance is called combination reaction. So, substance A react with substance B to form AB as a new product. This can be categorized as three different types. That is, two elements combine to form a compounds. Only elements. So, here two elements are combined to form as a compounds. We are taking example as a carbon. This is solid carbon reacts with the oxygen. Here carbon and oxygen are in solid states. When they are brought near to the heat, okay, so it produces carbon dioxide, CO2, which is a gaseous state. Also it produces some amount of heat energy. And this triangle is nothing but the short form of heat, presence of heat. This we know to be as a delta. Okay, and another example, that is Fe, that is an ion, element react with sulfur, produces under heating FeS, iron sulfide. Okay, so for these kind of reactions, heat is required to start. But once it started, it continues exothermally. So which means it releases some amount of heat energy. So through this method, various salts can be prepared. Okay, second category of this direct combination is a combination of an element and a compound. Okay, to give a new compound. Here example is carbon dioxide, carbon monoxide. Okay, not carbon dioxide. Carbon monoxide reacts with oxygen to form carbon dioxide. And these two are brought to heat. Here carbon monoxide is a compound and oxygen is an element. Similarly, sulfur dioxide in a compound and oxygen is an element have brought together, or when they come into contact, it produces sulfur trioxide. This should be 3, sulfur trioxide. So third one is two or more compounds combine to form a single product. So here the two reactants are compound only. Example, ammonia, which is in the gaseous state, and hydrochloric acid, HCl, hydrogen chloride, which is in the gaseous state. Both are taken into gaseous states. When these gases have come into contact and produces ammonium chloride, which is a solid. Further examples, we can take a calcium oxide. So this calcium oxide is otherwise known to be as a quicklime. Is been reacts with water. It produces calcium hydroxide, and this calcium hydroxide, which is in an aqueous state, and this calcium hydroxide is known to be as a slacked lime. So generally this slacked lime is used for whitewashing. So the newly constructed building, once they constructed, they used to give the whitewash, the first coating of the walls to the walls. And because of this coating, it produces a thin layer of calcium carbonate that protects the wall. And this layer of calcium carbonate which gives a shining surface also. Okay, right. Next one is reaction of carbon dioxide with water. This is simply we call it as a photosynthesis reaction under the presence of sunlight and chlorophyll. And this reaction occurs and it produces glucose. Okay, that is A6H12O6. And this type of reaction is also known to be as direct combination under two compounds, combination of two compounds. This we can learn by means of different experiments. Okay, for that first we are taking a lead sulfide. Here, lead sulfide is a black color. A black color lead sulfide is taken in a test tube and it reacts with the oxygen. Okay, so when it reacts with the oxygen, it produces PbSO4, nothing but lead sulfate, and this lead sulfate is brought by means of this combination reaction. Okay, so in the beginning lead sulfate is a black color, and this lead sulfate is black color, and the product lead sulfate is white color. Okay, then magnesium ribbon. Magnesium are being found in the ribbon. When this magnesium ribbon taken a piece and hold it in the flame, okay, so when it undergoes heat, it reacts with the oxygen present in the atmosphere to form as magnesium oxide. So how this magnesium oxide forms? When it reacts with the oxygen, it produces dazzling white light. It produces dazzling white light and turn up into magnesium oxide, forming magnesium oxide. Okay. Okay. Next one is the decomposition type of reaction. So what is the decomposition reaction? The chemical reaction in which a compound splits into two or more simpler substances, that is the elements or compounds, is called decomposition reaction. So the AB reaction, AB is a single reactant. AB is a single reactant, is undergoes reactions to form C plus D plus some more element also, which means it may decomposes to form only two product or more than two products. Understand? Okay. Decomposition is the breaking up of a compound either into elements or simpler compounds such that these products do not recombine to form the original compounds, which means under this product formation it cannot combine back and form as a new product, generally in the decomposition. And these kind of decompositions may occur in the presence of heat or light. Generally decomposition occurs in the presence of heat or light or by means of the passing of electric current. Okay, and these decomposition reactions which takes place three category. The first one is a compound. I mean a single compound breaks up into two or more elements. So here the compound we are taking is a mercuric oxide, HgO. This undergoes heating and it decomposes into mercury and oxygen, right? So this is the first category. Second one, silver chloride. And this silver chloride is in white color, and this silver chloride undergoes or showed in the presence of sunlight, it decomposes into silver and chlorine. So the silver which are forming is a green color and chlorine gas has been produced. Okay, so next one is on passing electric current, how it occurs. Water on passing electric current, it dissociates into hydrogen gas and oxygen gas. Okay, this is the first category, that is a compounds break up into two or more elements. This is by heating, this is by means of presence of sunlight, this reactions undergoes in the presence of electric current. Second one is a compound can break up to form both elements and compounds. One compound on decomposes to form an element as well as compound. Here we are taking an example of potassium nitrate. So this potassium nitrate is undergoes decomposition process to produces potassium nitrate, and also it gives oxygen. Okay. Further example, that is a compound can break up to form two or more new compounds. So one compound is decomposes to produces two or more new compounds. Undergoes heating. Example, we are taking calcium carbonate, undergoes heating. The temperature we are maintaining is 1000 degrees Celsius. On doing so, it produces two compounds. One compound is calcium oxide. CaO, and the other compound is calcium carbon dioxide. Okay, the other compound is carbon dioxide. So this is how this decomposition reactions occur. Further example in this category is FeSO4, ferrous sulfate. This undergoes heating. This white color ferrous sulfate undergoes heating to form ferric Fe2O3, ferric oxide, which is brown in color, plus sulfur dioxide plus sulfur trioxide. In this case, we can see that it forms three products. All three are compounds. Okay, students. Now, shall understand what is this thermal decomposition. So, we have learnt about decomposition. What is thermal decomposition? The thermal decomposition is a type of reaction that is brought about by heat without any recombination on cooling. So, I have get a product. The product on cooling cannot give any other product. Other words, I can say a decomposition reaction that is brought about by heat without any recombination on cooling is known as thermal decomposition. Okay, so they are called as thermal. These type of reactions are known to be as thermal decomposition. This thermal decomposition reacts mainly with the metal compounds. Metal compounds like metal hydroxides, metal carbonates, metal sulfates, bisulfates, metal nitrates. On these metal hydroxides, it reacts, it gives different products. What are they? When these metal carbonates, first we'll take metal hydroxide, like a potassium hydroxide, sodium hydroxide, calcium hydroxide, magnesium hydroxide, all these comes under metal hydroxides. And they have separated like a category. The first two, the next six or seven, and the last two. When these react with the sodium and potassium hydroxide are stable to heat. They undergoes heating are stable. Whereas if you take calcium hydroxide, magnesium hydroxide like that, it decomposes on heating, form their metal oxides and water vapor. And when it reacts with mercuric oxide and silver oxide, it yield a metal, the respective metal, oxygen and water vapor. So mercuric hydroxide on reacts on heating, it produces mercury, oxygen, water. Silver hydroxide produces silver, oxygen and water. Understand? Then metal carbonates. So metal carbonates means sodium carbonate, potassium carbonate, calcium carbonate, aluminum carbonate, all these are metal carbonates. So generally the first two category, it is stable to heat and soluble in water. They are soluble in water. And with the calcium, magnesium, aluminum carbonates, they decomposes on heating with a decreasing vigorous to form metal oxide and carbon dioxide. So first it decomposes on heating and the vigorous nature will decreases. The effervescence, the vigorous nature gets decreases on later and to form their metal oxides and gives carbon dioxide. These are the examples. Further, with the silver and mercury, it decomposes to form the metal, oxygen and carbon dioxide. Okay. The third one of this thermal decomposition, metal bicarbonates. That is metal hydrogen carbonate. When these examples like sodium hydrogen carbonate, calcium hydrogen carbonate, magnesium hydrogen carbonate. Only these three carbonates we should consider. We no need to consider about this other carbonates. They are not forming carbonates. Only these three produces bicarbonates. Sodium bicarbonates, calcium bicarbonates, magnesium bicarbonates. All these on heating up, it produces the respective carbonates and water and carbon dioxide. Okay, so this decomposition reactions is general naturally occurs in our body. When we are taking food, the digestion of food is nothing but the decomposition reaction. The food what we are taking into our body, like a starch, it decomposes into glucose and sugar. The proteins decomposes into form an amino acid, which build up our body, and the fats and oils are decomposes to form fatty acids. These fatty acids are stored as energy into our body. So, okay, so these are the a simple way to understand how this decomposition reactions occur in our body. Okay, then the continuation of this metal bicarbonates will come to the metal nitrates. These two, sodium and potassium, on heating, they melt and decompose to give metal nitrate and oxygen. Sodium nitrate and potassium nitrate, on heating, it decomposes to form metal nitrite and oxygen. So nitrate means NO3, nitrite means NO2, that respective metal nitrates. Okay, and further metals like calcium, magnesium, aluminum, they are decomposes to form metal oxides, nitrogen dioxide and oxygen. Okay, first it forms metal oxides. Last, mercury and silver, they form metal, nitrogen dioxide and oxygen on upon heating. Okay, students. Based on this, we'll have some experiment to understand about this thermal decomposition occurs between the various metals. First, we are taking a lead nitrate, and first equation, that is lead nitrate. A simple some crystals of, take some crystals of lead nitrate in a test tube and heat them. So when you're heating the crystals of lead nitrate, it produces lead oxide. This lead oxide is in yellow color solid. Also, it releases some gas. The reddish brown gas is nothing but the nitrogen dioxide gas. And oxygen gas, we know that colorless and odorless gas. Two gas it releases, one is oxygen, the other one is reddish brown gas. Second reaction or second experiment is reaction of zinc carbonate. And this zinc carbonate salt, okay, I've taken in a test tube and close the test tubes with a cork, okay, and heat up. So when you're heating, it produces zinc oxide and carbon dioxide. How we know that zinc oxide? The residue which are forming in the test tube at the bottom, when it is in the heat, when we're heating, it gives a yellow color. It's showing yellow color. After we cool down the test tube, it turns up into white. Understand? And the third one is ammonium dichromate. This ammonium dichromate actual color, salt color is orange. Orange colored ammonium dichromate. This upon heating, and once it starts heat, swell up. The substance gets swell up, and with a flash of light, it produces chromium oxide. This chromium oxide, once it obtained, the color in the test tubes is showing a green color solid, along with water vapor has been water. The water is formed as a steam or vapor state. Also, nitrogen gas released during this reaction. Okay. Then further, fourth one is the copper sulfate, hydrated copper sulfate. This hydrated copper sulfate color is blue color, taken in a test tube and start heat. When you start heat in the tilting position, it produces water vapor, and this water vapor can be seen in the inner side of the test tube. Also, you may notice that this copper sulfate salt, blue color copper sulfate salt, become colorless and become white anhydrous salt. Okay, and this is a kind of a reversible reaction. This copper sulfate salts, once when adding a few drops of water into it, okay, again convert back into hydrated copper sulfate, again retain the color of blue. Okay, so when the direction of chemical changes can be reversed by changing the condition under which the reactions is taking place. Such reactions are called reversible reaction. So we have seen 4 experiments in this. Out of this, the last one is reversible reaction. Why? From the reactant we got the product. From the product we can get back the reactant. So that is the example. One more example I can say for the same kind. For this iron react with water, it produces Fe3O4. Okay, this Fe3O4 produced along with hydrogen gas. On again, if this react with hydrogen gas, it again form as a Fe ion. Okay, this kind of reversible reactions can be shown by opposite arrows, both forward and backward arrow marks. So based on this, we'll have some experiments to understand this thermal decomposition. or thermal dissociation. So what is this thermal dissociations to show or to understand? For example, we are taking ammonium chloride. This ammonium chloride is on react to produces ammonia and hydrochloric acid. So take some amount of ammonium chloride test tube. Once we taken, it produces two gases or two colorless gas, ammonia and hydrogen chloride gas are produced, and these gases are moves upward. When heating, it moves upward, but the upper part of the test tube is cooler part. So again, what happened? A white color layer has been formed inner layer of the test tubes. That is nothing but the formation of ammonium chloride. So when heating, it decomposes, the gases goes ups, and there the temperature reduces, and again it cools down and forms as ammonium chloride. So this is a kind of a reversible reaction. A reversible decomposition reaction brought about only by heat is known as thermal dissociation. This is known to be as thermal dissociation. So you must know the difference between what is thermal dissociation and thermal decomposition. Understand? So one more example they are given is nothing but nitrogen tetroxide. This nitrogen tetroxide on heating, it changes into nitrogen dioxide. On this further cooling, it comes down to taken as a nitrogen tetroxide. Okay. Now, the third type of this reactions is displacement. Displacement reaction. What is displacement reaction? It is a chemical change in which a more active element displaces a less active element form its salt solution. So which means that when a highly reactive element displaces the less reactive element to produces a salt solution. So AB plus C gives AC plus B. Here A or the element C displace A from the compound AB and form as AC, or displace B from the compound to form as AC, and the B comes out separately. Okay, so this kind of reaction is called as displacement reaction. A simple experiment to understand this kind of displacement reactions like copper sulfate. So copper sulfates react with the zinc. So compared to copper, zinc is more reactive. So zinc displaces copper from the compound and occupy the place, so that it forms ZnSO4, zinc sulfate, and copper has settled down at the bottom. Okay, so this one example, and this when you're doing as an experiment, copper sulfate, which is a blue color solution of copper sulfate we are taking. In this, we are adding a zinc granules. So when adding zinc granules, it starts reactor, and the color of the copper sulfates, there is a blue color is faded up. Okay, and it forms as reddish brown particles. This reddish brown particles is nothing but the copper metal, and this colorless solution is nothing but the zinc sulfate. Okay, another example we can use, say, that is magnesium react with sulfuric acid. It form magnesium sulfate plus hydrogen gas. So magnesium displace hydrogen. And this third one is potassium iodide react with the chlorine. In this, chlorine displace iodine, okay, to form potassium chloride and iodine. Here zinc is more reactive than copper, magnesium is more reactive than hydrogen, chlorine is more reactive than iodine. How this reactiveness can be determined? That is what the next slide. This can be said by means of this reactivity series of elements. So the arrangement of metals of increasing order or decreasing order of the reactivity. So the topmost elements are most reactive. Potassium, sodium, calcium are most reactive, and keep going down. Platinum, silver, gold and all less reactive. The hydrogen is not a metal, but since the reactivity nature put up this element hydrogen between lead and copper. Understand? So in this the previous reactions we have seen this copper sulfate and zinc. So where is the copper present? Here. Where is the zinc present? Here. So copper zinc is top on copper. So zinc is more reactive than copper. So zinc displaces copper sulfate easily. Okay. Similarly, and we had another equations elements reactions between magnesium and hydrogen. So hydrogen is here and magnesium is on top. So magnesium is more reactive than hydrogen. So magnesium displaces hydrogen from sulfuric acid. Got it? And the other case is chlorine and iodine. But chlorine and iodines are non-metal. Okay, but they also have reactive nature. So that reactive nature is been put up like a fluorine, chlorine, bromine, iodine. So compared to iodine, chlorine is more reactive. So chlorine replaces iodine easily. Understand? So this is how how about this third type, that is displacement reaction. The other and the last type is double decomposition reaction. This type of a chemical change in which two compounds in a solution react to form two new compounds by mutual exchange of radicals. Double decomposition reaction is also called double displacement reaction. So this double decomposition reaction we can also say as double displacement reaction. Already we know displacement, highly reactive, displace less reactive. This it takes place in terms of double decomposition. It is also known to be as double displacement reaction. Okay, and this double displacement reaction we have two types. One is precipitation reaction, the other one is neutralization reaction. What is precipitation reaction? Precipitation reaction means we can easily understand that precipitate. Any reaction that produces precipitate is known as precipitation reaction. But the actual definition is a chemical reaction in which two compounds in their aqueous state react to form an insoluble salt, that is a precipitate, as one of the product is known as precipitation reaction. Okay, so precipitation is the formation of solid, that is the insoluble substance which are settling at the bottom. It can be colored or colorless, anything. When two solutions are mixed or when a gas is bubbled into solution. So when this precipitation occur, you must note that this two condition. When two solutions are mixed, first case, or when a gas is bubbled into a solution. When a gas is passes through to the solution, precipitations are possible. Okay, and example for this, we can take a barium chloride aqueous state, sodium sulfate aqueous state. When they have been come into contact, it forms barium sulfate, which is a white precipitate, and this sodium chloride aqueous state. So two aqueous substances combine to form one precipitate, white precipitate substance, and this kind of reactions is called as precipitation reaction. Okay, we know it is precipitation reaction. Why this comes under double decomposition reaction? Because barium displaces sodium, sodium displaces barium to occupy the alternate places. To understand this, we have experiment. We have first one silver nitrate. First one is silver nitrate. So silver nitrate on react with the HCl hydrochloric acid to form silver chloride and nitric acid. This silver chloride is a precipitate settled at the bottom. The color of the silver chloride is white curdy precipitate. What is the color? White curdy precipitate. And here also the silver chloride is white curdy precipitate. Third one, barium chloride react with sulfuric acid to form barium sulfate. This barium sulfate is thick white precipitate. How this barium sulfate looks? It's look like a thick white precipitate. Understand? So double decomposition reactions may also occur with evolution of gas. This case is two aqueous substance. Two solutions are combined to form precipitate. Here solution with a gas or the gas pass through the solution. Here what is the gas? FeS, iron sulfide react with sulfuric acid. So this is a solid and this is the aqueous state. Okay. So in this, when they are brought up together, it produces FeSO4. Ferrous sulfide is aqueous state and it produces H2S gas. This H2S gas, I am showing this upward arrow mark. Downward arrow mark resembles that formation of precipitate. Upward arrow mark resembles that evolution of gas. Understand? Similarly, zinc sulfide react with HCl. It produces zinc chloride and hydrogen sulfide. Okay, this is nothing but the reaction of or evolution of gas. Reactions with evolution of gas. This is also nothing but the, what is that type of precipitation reaction. Last type, nothing but the neutralization reaction. The neutralization, the reaction between an acid and a base. So one acid, one base reacts to form salt and water only. It produces salt and water only. No other product will be formed. They are referred to as neutralization reaction or reaction of neutralization. Example, sodium hydroxide base, HCl is acid, and they react to form sodium chloride is a salt and water. And why they are forms like this? Because they ionized, okay, and produces to changing the respective radicals, ions. To understand this, we are given this Na plus OH, HCl, H plus Cl minus. The same reactant we have mentioned here in terms of ions. So Na plus Cl minus. This Na react with this Cl to form NaCl, and this H react with this OH to form H2O, H plus OH minus, which is showing in the ionic form for better understanding. Okay, then this neutralization reactions, that is a soluble base. Soluble base is nothing but alkali, and it or an insoluble base react with an acid to form salt and water. So some of the example like sodium hydroxide, potassium hydroxides react with acids to form salt and water. And this with the insoluble base. These are soluble base and these are insoluble base. Lead oxide, copper oxide and all. Even then, with that it reacts with acids to form salt and water, respective salt. Lead oxide reacts with sulfuric nitric acid to form lead nitrate and water. Same as copper oxide, copper sulfate and water. Copper hydroxide means copper sulfate with water. Okay, children. Okay. So with that, we are ending with this types of chemical changes or chemical reactions. As the conclusions, we want to show say some applications of this neutralization reactions. And we are using this kind of neutralization reactions when any insects or bees bite our body. It produces formic acids and which gives pain, and to overcome this we are rubbing the particular area with a slacked lime or baking soda, and basic in nature to cure or to reduce the pain. Also, we have hydrochloric acid, HCl acid in our stomach, little at small traces. The main purpose for this is to decomposition reactions or to dissolve the food to antacid, which act as a antacid into our body. Okay, the segregated HCl, we experience pain, stomach pain, but this excess HCl can be relieved by taking milk of magnesia. This milk of magnesia is a base. Understand? And another one is any clothes. If suppose acid still in our body, it can be immediately neutralized by adding ammonia solution. Any ammonia solutions over it, that acid's effectiveness will be reduced. The blisters can be avoided, and immediately wash our particular area with water. Also, if the soil is somewhat acidic in nature, they are be treating with adding some base substances to make the soil fertile. Okay, students, with this the class is the topic types of changes, chemical reactions as end up, and we have one more video, that is energy changes in chemical reaction for exothermic and endothermic type of reaction. A small video. I'll put up the video in the next class. So go through this, watch the video completely for better understanding. Okay, students. Thank you.